Okay, welcome back everyone. So in the last lecture, we have started with a normalization and we have discussed what the normalization is, that is breaking a large table into a small number of tables. So for breaking, we have to look at a functional dependency. Now what the functional dependency is, let's check it here. Now let's say I have a one column age. Second column is date of birth. Okay, we can call it as a A, we can call it as a B. Now, can we say that if I get a date of birth, I can determine the age? Yes. So simply, we can say that A is determining B. So A will be the determinant, B will be the dependent. Simple. So now these both are functionally dependent on each other. Simple here. So simply we can say that this is functionally dependent on each other. Now here it's a direct that if you get a date of birth, you can find out the age. But sometimes what happened that this contact is depending on what? Name of the customer. Customer names defining the contact. So here we can say the customer name is determinant, contact is a dependent. So why we should be knowing the functional dependency? Simply, we have to break the table. So when we say we have to break the table, that means while breaking the table, all determinant and dependent must go together in another table. You cannot say that contact is going in another table and name is remaining here. If the contact is going out, so its determinant should also be along with that. That is a simple way of breaking the table. So for that, functional dependency is an important part. Very simple. Let's come here. So a functional dependency is a constraint between the two set. Now set means what? Sometimes it is not a single column, it could be a more than one determining the another. So that set considered as one determinant or one dependent. Simple here. Now, in functional dependency, why it is important? The determination of functional dependency is an important part of designing the database in relational model because it is helping us in normalizing and denormalizing the table. Normalizing means breaking the table. Denormalizing means joining the table. Simple. So functional dependency along with the attribute domain are selected to generate constraint that would exclude much appropriate data to the user domain from the system as possible. So simple here. Now, in functional dependency, there are certain rules that's called a functional dependency inference rules. In that, first is called a reflexivity. First is called a reflexivity. What's a reflexivity? If B is a subset of A, then A determines the B. Even if this dependency is not given, but if B is a subset of A, then A determines the B. What could be an example? Now for an example here, let's say, we can check it out here. Let's say we have a two columns. One column is full name and second column is only the first name. If anybody's full name is, let's say, Amitabh Bachchan, can you determine which will be the first name? If I get the full name, can I determine the first name? Yes, that is Amitabh. So here, this is A, this is B. B is a subset of A, so A determine the B. And this is called as reflexivity. This is called as a reflexivity. Augmentation. Next rule is called a augmentation. Augmentation is an extension to the reflexivity. If B is a subset of A and C determine the D, then A and C determine B and D. Quite logical and common sense. If B is a subset of A, then can we say A determine the B? Yes. Just now we have seen with the help of reflexivity. And C determine the D. This given. C determine the D. So now if I get the value of A and C, can I determine the value of B and D? That's the only called as augmentation. If B is a subset of A and C determine the D, then A and C determine B and D. So simple. That's a augmentation. Next is called a transitivity. I'm sure everybody know the transitivity. Transitivity means what? If A determine the B, B determine the C, then you can say A determine the C. Very simple. If Ramesh in the class because of Suresh and Prakash in the class because of Ramesh. So can we say that Ramesh determine the Suresh, Suresh determine the Ramesh, Prakash. So indirectly, if Ramesh is there in the class, then the Prakash is in there in the class. That is a transitive. A B को डिटरमाइन करता है, B C को डिटरमाइन करता है, then हम बोल सकते हैं कि A भी C को डिटरमाइन करता है. That is not direct but a transitive. Very simple. B is directly determining the C and A directly determining the B. Indirectly, A determining the C. That's called a transitivity. After the transitivity, pseudo-transitivity. Again, this is an extension of transitivity. If A determine the B and B and C determine the D. Pay attention carefully. If A determine the B and B and C determine the D, then A and C determine the D. Very simple. A determine करता है B. B C के साथ मिलके determine करता है D को. अब इसमें B किसकी वजह से है? A की वजह से. So A भी C के साथ मिलके किसको determine कर सकता है? D को. क्योंकि A से क्या मिल जाएगा हमको? B और B and C determine the D. So we can say that A and C also determine the D. Clear? Yes. So after the pseudo-transitivity, next, union. The word or name itself described that union means what? combination, combining, union. So अगर A B को डिटरमाइन करता है, अगर A C को डिटरमाइन करता है, so can we say A B और C दोनों को डिटरमाइन करता है? Now look at technical part here, simply. We can say that A, just I have already written here, A determine the B. Okay, it's not come. Let's see it here. Control C, Control V. Okay, A determine the B, and we can write it here again. And here we can say A determine the C. So can we say that A determine B comma C? So this is called the union. Simple. And this is called as decomposition. This will be called as a decomposition. This will be called as a union. Very simple. अगर A individually B को determine करता है, अगर A individually C को determine करता है, मतलब A B और C को साथ में determine करता है, will called union. Simple. After the union, decomposition. Just now we have taken an example, opposite to union. That's called a decomposition. Very simple here. Now, after the decomposition, last one is called a trivial functional dependency. What's the meaning of trivial functional dependency? Some functional dependency are said to be trivial because they are satisfied by all relation. Now, definition wise, it is a little bit difficult to understand, but in simple words, look at here. Here we can say age determine the date of birth. So can we say A determine the B? Yes, but it is not a trivial, because in the trivial, value of this and value of this also must be the same. Age will be some different number, date of birth will be the some different dates. That's not a trivial. Trivial means आपके determinant और डिपेंडेंट दोनों की वैल्यू भी ऑलमोस्ट सेम होनी चाहिए. कब हो सकता है ये? ओनली इन अ टू केसेस. वन, इफ ए डिटरमाइन द ए. सो कैन आई से एज डिटरमाइन द एज? सो दोनों एज सेम ही होंगे बिकॉज द सेम इज डिटरमाइनिंग द सेम. एंड सेकेंड, ए डिटरमाइन द बी and B is a subset of A. A determine the B and B is a subset of A. Now here, Amitabh Bachchan, this Amitabh and Amitabh, same value. So this will be considered as a trivial functional dependency. If A determine the A, X determine the Y if Y is a subset of X. That's called a trivial functional dependency. Very simple. Now, on this functional dependency, what type of questions comes? Mostly, functional dependency is given to you, and you have to determine the candidate key. Okay, let's talk about one question, then we go ahead. Okay. Can I remove all this? I'm just keeping this for copying purpose. Just I'm deleting now. You have been given one relation, and in that relation, you have been given certain attributes. A, comma B, comma C, comma D, comma F, comma G. Let's say this is given to you. Apart from this, you have been given certain information of dependency. So one information is given to you is A determine the C. Second information is given to you is B determine D, comma F. Okay. And third information is given to you is G is subset of D. G is a subset of D. And the question is find candidate E. So how to find? It's very simple. So whatever the method you know, you can use that as well, plus a simple method I'm going to show you here. Now, based on this, create a small network. First, write a A. Here A determine the C, so we can write a A. A से कौन सी वैल्यू मिल जाएगी हमको? C की. Write the C. C से कुछ मिल रहा है आगे? It's not given. So leave this here. Then come to this B. B से क्या क्या मिल जाएगा हमको? We will get the D and we will get the F. Okay, so B से क्या मिलेगा? D और F. Plus it is given G is subset of D. मतलब D determine the G. So D से कौन सी वैल्यू मिल जाएगी हमको? So now check this. A, B, C, D, G, F. So A, B, C, D, F, G. So we have a 1, 2, 3, 4, 5, 6. Do we get all 6 here? 1, 2, 3, 4, 5, 6. Yes. After writing this, whichever is the topmost layer, that will be the candidate key. So your candidate key will be now A, comma B. Simple. That means once you get a value of A and B, you can determine all other values. That's a candidate. So simple. So this is how you can find out a candidate. Let's move ahead. Now we'll talk about normalization. Now normalization is nothing but breaking the table, correct? But can we break from anywhere? No. We have to follow certain rules. And based on that rules, that particular structure comes to a specific normal form. So we have a certain normal forms here. First normal form, second normal form, third normal form. They are coordinately called as 1NF, 2NF, 3NF. So in the industry, we have to go only up till the 3NF. Rest are called as a higher normal forms. That is a BCNF, 4NF, 5NF, also called as PGNF, and DKNF is a domain key normal form. So we will talk in detail up till the 3NF and one-liners for next. So for the first normal form, what to be done for the first normal form? Give me a second. Okay, so for the first normal form, how will you say that your structure is in first normal form? So for that, you have to apply certain rules. Now we'll talk in a very simple method. So for the first normal form, you have to follow the two rules. Apart from these two, one is a compulsion part that each normal form must have a primary key. Apart from the primary key, we are talking about the two major rules. So the rule number one, that each field should contain a smallest meaningful value, or you can call it as atomic value. That means आपकी जो values है, that should be the atomic and should not be further divided. Then we can call it as smallest meaningful value. And second rule, that it should not contain repeating group of fields. What do you mean by the repeating group of fields? Now we have taken one example here. In this, we have a column product. If I have one more column as product, can I say that this and this both are of the same group of field? इसमें भी product का नाम आएगा, इसमें भी product का नाम आएगा. So this is not allowed. Simple, only the two rules. Rule number one, atomic data. Rule number two, no repeating group of fields. If you conform these two things in your structure, then it will be considered as 1NF. Then it will be considered as 1NF. Now, this is the example we have taken. Now, this table is violating the first normal form. What is the violation here? I have tried to make a two structures, 1 and 2, but both are violating. Reason is, first rule, that it should not have multiple values. It should be having an atomic value. So that's why we have done it here. But here also the second rule is getting violated, and that's called repeating group of field. Here house A, B, and C. It's nothing but a repeating group of field. Yeah. So what will be the solution for this? In the first normal form, redundancy may increase. In the first normal form, redundancy may increase, but that rule must be applied. So we can make it something like this. Part, warehouse, and we have added one extra column. If it is not required, you cannot, but it will be the two something like this. So you can see that redundancy has increased 10, 10, 10 multiple times. B, B multiple times. But it is allowed in first normal form. So remember, for the first normal form as two rules. Rule number one, no repeating group of field. Rule number two, each field must contain atomic data. And primary key is always a compulsion part for each and every normal form. Clear? Now, one thing to be remembered, that each normal form is the higher version of its previous normal form. So when we talk about 2NF, 2NF is the higher version of 1NF. That means it should fulfill all the requirement of 1NF as well, plus something extra. Correct? I'll repeat once again. Each normal form is a higher version of its previous normal form. So it should fulfill all the requirement of previous normal form, additionally something extra for that normal form. Now you can see that primary key cannot be the 2. So understand, it's not a 2 primary key. It's a 1 primary key containing the 2 columns. So it is called as composite primary key. So for the second normal form, mostly we used for those structure which is having a composite primary key. Correct? So what is the rule? So the rule is, first we have said that usually used in a table with a multiple field primary key or composite key. Now, first thing, it should fulfill all the requirement of first normal form plus what? Extra. Now, extra is only one important part, and that part is each non-key field. What do you mean by the non-key field? The column which are not a part of primary key is called as non-key field. Clear? So each non-key field must depend on entire primary key. Here the important is entire. What do you mean by the entire? Understand here. Let's say here we have something. Okay, let's say we create one table here. Okay. In this, we have a column A, column B, column C, D, and E. Assuming that A and B is a primary key. Okay, so we can say A and B is a primary key. So can we say C, D, and E is non-key field? Correct? Now, value of C depends on A and B both. So can we say C is depending on entire primary key? Yes. D's value is also depending on A and B. So can we say that C and D is totally depending on A and B? But E is depending only on B. E depends only on B. So in that case, E is not depending on entire primary key. It is depending on only partial primary key. So this column is violating the second normal form rule. So this column does not have a right to stay in this particular table. It has to go out. But when this will go out, what the rule we have learned? इसके साथ इसका डिटर्मिनेंट भी बाहर जाना चाहिए. So this will also go out. यहां भी रहेगा और यहां भी रहेगा. क्यों? क्योंकि हमको रिलेशनशिप भी मेंटेन करनी है. क्लियर? ये अब भी इसके साथ रिलेशनशिप मेंटेन करेगा. सो वी हैव एक टेबल को काट के हमने दो टेबल बना दिए. सिंपल हियर. सो दैट इज अ सेकंड नॉर्मल फॉर्म. वेरी सिंपल. So simply you can say that in second normal form, usually used in table with a composite primary. Why composite? क्योंकि अगर वो सिंगल फील्ड है और नॉन की फील्ड उस पर डिपेंड कर रही है, मतलब वो एंटायर की पे ही डिपेंड कर रही है. करेक्ट? So after the second normal form, we'll move to the third normal form. But before going to that, let's look at this example. Now this is violating the second normal form. Just have a look at this and check for a minute. What is the violation here? Okay, so you have looked at this. What violation you have been found? So here, if you look at this, can we say part and warehouse is a primary key? That is a one field or a composite field? Obviously, it's a composite field. Quantity and warehouse address is a non-key field. Now, this quantity is of this product at this warehouse. I'll repeat once again. This quantity is of this product at this warehouse. मतलब अगर प्रोडक्ट चेंज हुआ तो भी क्वांटिटी अफेक्ट होगी, वेयरहाउस चेंज हुआ तो भी क्वांटिटी अफेक्ट होगी. That means quantity depends on entire primary. But if you look at warehouse address, ये एड्रेस का पार्ट से कोई लेना देना नहीं है. This is depending only on warehouse. पार्ट चेंज हो गया, इस पे कोई फर्क नहीं पड़ेगा, एड्रेस वही रहेगा. That means it is depending only on warehouse, not on the part. That means it is depending on partial primary key. Correct? Now, hence, it is depending on partial primary key. This is not allowed here. It should go in a different table. So when it should go in a different table, अकेला बाहर जाएगा नहीं, इसका डिटर्मिनेंट भी बाहर जाएगा. तो इसका डिटर्मिनेंट कौन है? वेयरहाउस. सो रिजल्ट विल बी समथिंग लाइक दिस. वेयरहाउस डिटर्मिनेंट है, एड्रेस वायलेट कर रहा था, प्लस ये इसके साथ में रिलेशनशिप भी मेंटेन कर रहा है. क्लियर? Very simple it was. Now, after the second normal form, the third normal form, usually used in a table with a single field primary key. मतलब यहाँ पे कंपोजिट प्राइमरी की अलाउड नहीं है. करेक्ट? और यहाँ का रूल क्या है? सिंपल रूल that each non-key field must depend on primary key directly. Now directly is an important word. मतलब transitive dependency allowed नहीं है. So simple. I'll repeat once again. Each non-key field must depend on primary key directly. Very simple. So two rules. Rule number one, primary key has to be a single and each non-key field must depends on primary key directly. So transitive dependency is not allowed. Now take an example. In this, we have an employee number, first name, last name, work department, and department name. Very simple. Now in this, can we say that employee number is the primary key? Rest are non-key fields. Out of this, first name, last name is a group of field, right? So this is the name. Can we say this name is of employee number? Yes. Can we say this is the department number of this employee number? Yes. But if you look at department name, this is a name of this department number, and this department number is a department number of this employee number. That means this depends on this depends on this. So can we call this as a transitive dependency? A determine the B, B determine the C, indirectly A determine the C. But third normal form does not allow the transitive dependency. कौन सा कॉलम बाहर जाएगा? Which column will go out? Obviously, department name. But अकेला बाहर जाएगा? नहीं. इसका determinant भी बाहर जाएगा. Correct? So, this will be the final result. This will create a relationship and it has gone out. Very simple. So you have to be clear up till the third normal form. Simple. You have to be clear up till the third normal form. Now, let's move ahead. Do something practical. Let's assume this is an unnormalized table. We have to normalize it. How do we normalize? Each normal form is a higher version of previous normal form. So first, we have to look for the first normal form. So when we talk about the first normal form, in that case, we have to look for the first normal form. So in the 1NF, what rules we'll check? No repeating group of fields. Second, value in each field must be atomic. So let's go for the first thing. Find a repeating group of fields. Okay, check a minute, and can you see the repeating group of field here? Yes, there is a repeating group of fields, and that is actor and actor 2. तो अब इसका क्या करना पड़ेगा? This is not allowed. Actor 2 should be a part of actor, and it will be something like this. अब actor 2 के जो records हैं, इनके लिए भी पूरी values आएगी. So it will become something like this. Now we can see that repetition has increased, but 1NF allow the redundancy. Simple here. So we have to look for a second thing now. Atomic data in each field. Do we have atomic data? No, we don't. Amir Khan, Anushka Sharma. So can we say that can be divided into the two? First name, last name. First name, last name. Simple. So it will become something like this. Now, let's reduce the data. Now we have to look for the second NF or third NF. Now we have seen that 2NF and 3NF are almost the same. What's the difference? One major difference is single field primary key or composite primary key. So let's decide a primary key here. Obviously, we are going to choose the movie as a primary key. So it's a single field or a composite field, single field. So we can directly look at 3NF. So what's the rule of 3NF? Each non-key field must depends on primary key directly. Simple. Does Amir Khan depends on PK? No, क्योंकि अगर ये सिर्फ PK पे डिपेंड होता तो 3 Idiot में आमिर खान नहीं होना चाहिए. Correct? Does actress depends on this? No. But this duration is depends on the movie. So these two things, 1 and 2, has to go out. Correct? Now when this is going out, only this much is remaining. But we have learned that only breaking is not a solution. We have to create a relation between them. How to create? So first decide what type of relationship is there. 1 to 1, 1 to many, or many to many. It's a many to many. One movie can have a many actor. One actor can act in a many movies. One movie can have a many actress. One actress can act in a many movie. One actor can have multiple actresses. One actress can have multiple actors. So it's a many to many. So when we say many to many, then how do we create? We create a third table for creating a relationship. third table will be the child of all these three. मतलब थर्ड टेबल में क्या होगा, फॉरेन कीज, इसमें क्या होंगे, प्राइमरी कीज. So we don't have a primary key, so we can add it here. Actor ID, actress ID, movie ID, and we create a third table. उस third table में क्या होगा, movie ID, actor ID, and actress ID. Now, can we say all are related with the help of this table? Yes. So this is the final structure of unnormalized structure. Clear? Okay. Now talk about a normalization in the short. First, unnormalized. What is unnormalized? Flat files. 1NF. क्या करना है उसमें? Remove repeating groups. ये वन लाइनर्स याद रखने में बहुत इजी रहता है. 1NF, remove the repeating groups. 2NF, remove partial key dependency. And 3NF, remove the transitive dependency. Direct dependency ही होनी चाहिए. Okay. So repeat it once again. 1NF, remove repeating groups. 2NF, remove partial key dependencies. 3NF, remove transitive dependencies. So now we are expert up till the 3NF. Next also we'll talk in a one line. PCNF is also called as 3.5 NF. So till now we have seen that सारे dependent किस पे depend करते थे, primary key पे. That means primary key was a determinant. Sometimes it is not possible, so we go for the BCNF. So BCNF में every determinant is a candidate key. Next is 4NF. Just next to this, every determinant is a super key. यहाँ पे candidate key, यहाँ पे super key, or it contain no multi-value dependency. 5NF or PGNF. PGNF full form is project join normal form. So here everything depends on project based. Last is a DKNF. So here all the determinant is a domain key. Simple. So with simple this we completed the normalization.